Hello class. So for this video, we'll be discussing Laplace transforms of functions. Yan. So first, let us define muna ano ba yung Laplace transforms. So the Laplace transform, it is a widely used integral transform with many applications in physics and engineering. So yung operation niya is denoted by this symbol. So letter L na parang cursive, and then the function that is to be Laplaced. So it is a linear operator of a function f of t with a real argument. T is equal, ang t natin is t is greater than or equal to 0. That transforms it to a function f of s with complex argument s. So this was invented by Pierre Simon Laplace, who was a French mathematician, astronomer, physicist, who applied Newtonian theory of gravitation to solar system. So this is him. Ayan, lumang picture niya. The main idea, class, behind the Laplace transformation is that we can solve an equation or a system of equations containing differential and integral terms by transforming the equation into t space to 1 in s space. So the reason, class, kung bakit included si Laplace transform in differential equations is because we are going to use that transform in solving differential and differential equations. So instead of yung, di ba meron tayong different methods na pinag-aralan last time, like nag-aral tayo how to transform homogeneous equations, linear equations, or various differential equations, yung mga pinag-discuss natin last time. So in this chapter, we will be introducing a new method to find the solution to differential equations, and that is through Laplace transform. So these kinds of problems, very invaluable sila in electronics, or madalas lumalabas siya in electronics. So the Laplace transform, class, it is defined as, by the way, yung operator natin, to make it simple, ano lang siya, L na ito. So, but don't be confused. So, ito lang din yun. So, mahirap lang siyang ulit-ulitin sa pagta-type. So, that's why ito na yung gagamitin natin na symbol from now on. So, the Laplace transform daw, class, it is defined as the integral from 0 to infinity of e raised to negative st f of t dt. So, this is the definition of Laplace transform. Now, take note, kung napansin, we have an integral or upper limit and lower limit na infinity and 0. So, remember, class, in your integral calculus, that when both or either one of the upper limit or lower limit is an integral approach that approaches infinity, then it is an improper integral. So, this Laplace transform, class, it is an improper integral. Yeah, now let us try to apply the definition sa mga simple lang muna na mga functions. So using the definition previously discussed, let us try to solve for the Laplace transforms of frequently occurring functions, such as this one. So take the Laplace transform daw of f of t is equal to 1. So ang f of t natin is just 1, or to be general, a constant. So first, substitute muna natin yung function dun sa equation natin. So this is our equation as defined earlier. So substitute lang natin yung f of t dito, and f of t natin is equal to 1. So we will arrive at the integral of 0 to infinity of e raised to negative st times 1 dt. Now, what we do now is we integrate. Now, after integration, ito yung lalabas. So pag in-integrate natin to, this is e raised to negative st. So, alam naman natin yung integral niyan. So, that is negative 1 over s, e raised to negative st. And then, ang upper and lower limits natin is infinity and 0. Now, evaluate natin siya. So, we'll have negative 1 over s, e raised to negative s, yung t palitan na natin ng infinity, minus negative 1 over s e raised to negative s times 0. So take note, ito ay magiging e raised to negative s times 0. So 0 times negative s, that is equal to 0. So this will be equal to 1. Ayan. So this will be equal to 1. Next is, so paano naman to? We have infinity. So paano natin yun evaluate? So take note class, we have here negative s times infinity. Since hindi natin alam kung ano yung value nito, we can assume that this is just a very, very huge na number. If this is a very, very huge na number, tapos may negative dito, then as we approach infinity, what will happen to the value of e raised to negative s? Diba ang mangyari dyan class is habang yung power natin or exponent natin ay mas nagiging negative, bumababa yung value nitong term na to. So therefore, as we approach infinity, the value of this term approaches 0. So pwede na lang natin tong palitan as 0. So yan. So yan yung pinaliwanag ko kanina. So therefore, yung Laplace transform natin will be 0 plus 1 over s times 1. Ang Laplace transform natin ngayon is simply 1 over s. So this is our Laplace transform. Next, we have another example. We have find the Laplace transform daw of f of t is equal to e raised to negative at, where a is a constant. So let's try that. Substitute din muna natin yung function dun sa equation. So we will have, ang f of t natin is e raised to negative at. Now, ang gawin natin class, since parehas naman na ang base natin ay e, so pwede natin i-factor out yung t. Pag finactor out natin yung t, yung exponent niya will be a minus s times t. So yung equation na kakalabasan natin is integral from 0 to infinity of e raised to negative a minus s times t dt. Now, if we integrate this, so power rule lang din sa ano, kumbaga integral ng exponential function. So we have 1 over a minus s times e raised to negative to a minus s times t, then from 0 to infinity. Now, take note class, dito is very obvious na. If yung a minus s natin is greater than 0, then the value of e raised to a minus s times t diverges, meaning nagda-diverge siya, hindi siya nag-converge into a value. It diverges palabas. It doesn't converge to a single value. And therefore, it will approach infinity. Thus, the Laplace cannot be defined. So, if ang range natin ay gagamit tayo na ang a natin minus s is greater than 0, so meaning itong a na to is mas malaki kesa sa s natin, it will approach infinity. And wala tayong Laplace na makukuha doon. Kasi in the first place, paano natin siya evaluate? Eh, hindi naman converging yung yung term na yon. So therefore, we can only proceed by assuming that yung a minus s natin will be less than 0. Kasi kapag less than 0 siya, sure tayo na negative yung value. Kahit i-multiply natin yan sa infinity, kasi yung t natin, di ba, papalitan natin yan ng infinity mamaya. Kahit i-multiply mo yan sa infinity, alam natin na magko-converge to 0 yung term na e raised to a minus s times t natin. Evaluating the result, and assuming that yung value ng a minus s natin is less than 0, we'll arrive at this one. We have 1 over a minus s times e raised to a minus s times infinity minus e raised to a minus s times 0. So this will become 1, as e raised to 0 is 1, and this will become 0. So we will arrive at 1 over a minus s times 0 minus 1. So therefore, yung ating Laplace is negative 1 over a minus s. Or pwede rin natin isulat to as 1 over s minus a. So this is our Laplace. Now, sir, kailangan po ba na ulit-ulit ay gagamitin natin tong definition ng Laplace. Diba? So, medyo mahaba siya. Tapos, ang ginagawa lang din naman natin is nag-integrate tayo ng paulit-ulit. So, therefore, merong mga patterns or formats or templates na tayo na pwedeng sundan. Ayan. So, ito yung mga yun. So, we have this table of Laplace transform. Just take note, class, na kapag ginamit natin tong table na to, it means na nag-integrate tayo. So, ganun class yung ginawa natin. So, mapapansin, ito yung kanina. Laplace pinahanap sa atin yung Laplace of 1. And nag-arrive tayo with the same answer as 1 over s. So, pinahanap sa atin yung Laplace ng e raised to at. Nakuha din natin tong sagot na to. But yung condition natin is dapat mas malaki yung s kaysa sa a. Kasi, di ba, kung babalikan natin, if yung s natin is less than a, ang tendency is we will have a value of exponent na greater than 0. So, magiging positive times infinity tayo. So, kapag ganun, hindi natin siya ma-evaluate. So, kaya ang assumption natin or ang condition natin is dapat mas malaki yung s kaysa sa a para sure tayo na negative yung multiply natin sa infinity. So, mag-approach ng 0 yung value niya. So, yan. We also have for t raised to n. So, we have n factorial over s raised to n plus 1. So, nakalagay din naman yung condition or yung range at which they are applicable. So, meron din tayo for cosine and sine. Ito siya. We also have for combination or product. Kung mapapansin nyo, itong t sine omega t, that is the product of t, this function, and this function. So, we also have the transform for this one. So, I suggest na gamitin natin talaga yung Laplace transform. Pwede nyo pa rin naman gamitin yung definition. But syempre, medyo mahirap na siya. Kumbaga, paano pag complex na yung yung function, so baka kailangan na nating mag-integration by parts, mag-partial fractions, etc. So, magiging mahaba yung process. So, dapat alam natin kung paano gamitin tong table. So, apply natin ngayon tong table na to the problems later. But before that, some properties muna tayo. We also need to be familiar with the properties of Laplace transform para alam natin kung paano ba nag-work yung operator na yun and paano nadi-distribute ba siya, paano ba yung mga functions natin, etc. etc. So, first one is the constant multiple. So, if let's say for example, you have a and it's a constant and f of t as a function of t and nakamultiply silang dalawa. So, we have the Laplace of a times f of t. We can simply factor out a and magiging a na lang siya Laplace of f of t. So, pwede nating tanggalin yung constant na multiplier niya or ilabas yung constant na multiplier niya. Next, we have property 2, linearity property. So, if a and b are constants while f of t and g of t are functions of t, then, so, pwede rin na i-apply natin siya dito. So, our Laplace, pwede natin siyang i-distribute. Since, as mentioned earlier, linear operator yung Laplace transform natin. So, we have Laplace ng a times f of t plus b times g of t can be distributed yung operator natin to a times Laplace ng f of t plus b Laplace ng f of t. G of t. Sorry. G of t. Next is change of scale property. So, with this one, let's say for example, ito given naman na to. This is the basic definition. So, by the way, class, yung Laplace transform, in-express na natin siya, di ba, sa f of s. So, kapag sinabi natin capital letter of s, so we are referring to the Laplace transform of yung small letter niya. Small letter niya, tapos in the t space. So, we have Laplace ng f of t is equal to f of s. Then, kung merong tayong constant na nakamultiply dun sa t natin, let's say for example, f is equal to a of t, nilagyan natin ng constant dun, then the Laplace transform will be this one. And that is 1 over a times f. Yung s, papalitan natin ng s over a. So, ganun lang kasimple. So, ang mangyayari sa class, halimbawa, given na tayo, meron na tayong f of s na nakuha. Tapos, ang ginawa is, yung f of t, instead na f of t, ginawa mo siyang f of at. So, gagayahin lang natin to. I-multiply natin siya sa 1 over a. Pagkatapos, yung s is papalitan natin ng s over a. And then, i-simplify na natin yung equation. Next, we have property 4, shifting property. And that is, if we have L, or the Laplace of e raised to at, f of t, then the Laplace transform is f s minus a. F of s minus a. So, kung merong e raised to a constant times t na nakamultiply sa f of t mo, so the Laplace transform is simply the Laplace transform of ft, pero gagawin mong, yung s mo is gagawin mong s minus a. In property 5, wala siyang pangalan. That is, if you have the pinapanap sa yung Laplace transform of t, which is your argument, times f of t, then it is equal to negative f prime of s, meaning the first derivative of your f of s. So in short, pwede mo rin ito express as d over ds times f minus s, f of s, kumbaga. So, kumbaga itong negative f prime of s, you can express this as negative d over ds, or the derivative with respect to s of f of s. Ayan. So now that we know the sum of the properties and familiar na tayo dun sa table natin, we can now solve for Laplace transforms. So we have first example, we are asked to get the Laplace transform of t squared plus 4t minus 5. So using property 1 and property 2, so that is yung constant multiple at saka yung natin, linearity property. So pwede, bilang sabihin nun, yung Laplace operator na to, pwede mo siyang i-distribute sa mga to, linearity property. And pwede mo ilabas yung 4 kapag ilalaplace mo yung t. So we will arrive at the Laplace of t squared plus 4 Laplace of t minus Laplace of 5. So, from the table of Laplace transforms, so hanapin muna natin, we have Laplace of t squared. So, ito siya. So, we have t raised to n. Ang Laplace niya is n factorial over s raised to n plus 1. So, substitute lang natin yun dito. Or, lang natin, palitan lang natin siya ng ganyan. So, we have, ang n natin dito is 2. So, therefore, for the first term, ang Laplace niya is 2 factorial over s cubed. Next, this is for Laplace of t. So, ito yung Laplace of t natin. And Laplace of t natin is just 1 over s squared. So, 4 times 1 over s squared. Plus, Laplace of a constant is this one. So, we have 1 over 1 and that is 1 over s. So, this is 5. So, we have 5 over s. So, kung hindi kayo convinced, parang ito lang kasi yan, di ba? So, we have L, 5L times 1. So, ito rin yun, kumbaga. So, kapag constant, that's just the constant over S. Yun lang yung Laplace transform natin. So, therefore, ang answer natin, class, will be 2 over S cubed plus 4 over S squared plus 5S. So, that is our Laplace transform. Now, take note na that this is for S is greater than 0. Kasi kapag hindi yan greater than 0, ang tendency niyan, class, is magkaroon tayo ng diverging yung mga terms natin. So, hindi natin siya malalaplace transform. Remember, shortcut lang natin yung operation na ginagawa natin kanina. Instead of using the definition of integral of Laplace transform, which is yun nga, the improper integral from 0 to infinity, of e raised to at, e raised to as minus times f of t. So, hindi natin makukuha tong mga answer na to. So, take note, dapat sundin natin yung interval na yan. Next, another example, we have obtained daw the Laplace of t raised to 4 e raised to negative jt. So, for this one, hanapin na lang din natin ulit siya doon sa ating table of Laplace transform. So, kung mapapansin natin, siya ay ito. We have this one. We can use this, this is similar rather to this time function. So, therefore, from the Laplace table, we have ito nga, e raised to negative 80, ang a natin is negative j, times t raised to n, ang n natin is 4, that is equal to n factorial over s minus a raised to n plus 1. Substitute natin. So we will have 4 factorial over s minus negative j raised to 4 plus 1. So therefore, ang answer natin is 24 over s plus j raised to 5. So this is our Laplace transform. Next example, we have obtained daw the Laplace transform of t e raised to negative t cosine 4t. So kung napapansin, itong function na to is medyo mas mahaba na siya. We actually have 3 na products ng mga functions na inaano natin kanina na identify. So for this one, wala yan directly katumbas dun sa table natin. So what we can do is we use property 5. And that is L times T, L of the Laplace of T times G of T or F of T, pero in this case, G of T yung ginamit natin, baka malito, is equal to negative G prime of S, and negative G prime of S is just negative D over ds of G of S. So we just substitute that. If we will use this, kasi pansin natin, meron tayong nag-iisang t dito, di ba? So pwedeng ito yon. So therefore, itong natirang to, that is our G of T. So ang G of T natin is e raised to negative T cosine 4t. Now, kung titingnan natin, we need to have, ito, pinakamadali kasi tingnan dito sa last equation na to. So, makikita natin class, we need G of S. Diba? So, we need to get G of S muna. So, that is why, to get G of S, we just need to get the Laplace of G of T. So, G of S natin, therefore, is the Laplace of G of T, which is e raised to negative T cosine 4t. Now, itong e raised to negative T cosine 4t, this is already in the Laplace table. So, in the Laplace table, so this is simply equal to S plus A, yung nandito nakasulat, over S plus A ulit, tapos squared plus, ito, yung 4 na to, omega raised to the 4th. So, ito siya. So, pakita natin sa Laplace table. So, from our example earlier, ito siya. Ayan. So, dito natin siya binase. So, we have S minus A over S minus A squared plus omega squared. Yun yung ginamit natin to find the Laplace transform of this one, this equation. So, therefore, we will arrive at S plus 1 over S plus 1 raised to 2 minus 16. Simplify natin, we have S plus 1 over S squared plus 2S plus 17. So that is our G of S na. Now, what we need to have is the derivative of G of S. So we need to apply this operator as well. So tanggalin muna natin, wag muna natin pansinin yung negative. Kunin muna natin yung derivative ng G of S natin. So the derivative of G of S natin is the derivative of S plus 1 over S plus 1 squared plus 16. So, which is this one. So, hindi na nakasimplify kasi easier siya. So, to do that, ito pala. So, sinimplify din natin. To do that, we have to do quotient rule. So, kasi kung napansin, this is a quotient. So, using quotient rule, so we have VDU, UDV minus VDU over V squared lang naman yan. V squared. Ayan, sorry. Nawala yung squared dito. Nawala yung squared dito. So, una is, VDU muna. Tama ba? VDU pa. Ang tama palang quotient rule is VDU minus UDV over V squared. So, ang VDU natin is V times DU natin is the derivative of U, which is S plus 1. So, ang derivative niya is just 1. Minus UDV, U natin is S plus 1. V natin is 2S plus 2. Tapos, ito is 0 na yung derivative ng 17. Over V squared. So, simplify natin. we will have negative s squared minus 2s plus 15 over s squared plus 2s plus 17 squared. Let's further simplify pa. Ang gawin natin is ilabas natin yung negative kasi ano to, 'di ba? Negative s squared minus 2s plus 15. So alanganin. So lalabas natin yung negative natin. Also, maganda rin na nilabas natin 'yan kasi remember, kailangan pa natin siyang i-substitute dito. So ine-negative natin. So mas madaling i-evaluate yung mga negative na sign. So substitute na natin siya to this equation. We will have the Laplace of f of t is therefore equal to negative of negative s squared plus 2s minus 15 over s squared plus 2s plus 17 squared. So this is simply the answer. So s squared plus 2s minus 15 over s squared plus 2s plus 17 raised to 2. Yun. So, ganun lang siya. Kailangan lang familiar tayo or alam natin kung paano gamitin yung mga property niya, which is basically ano lang talaga siya. Simple mathematics lang. Simple na pagsusubstitute. Tapos, syempre, kailangan, as I have emphasized naman in the previous topics, we should have mastered integration and differentiation na. Another example, that is, find the Laplace daw of g of t is equal to t cosine 7t, but may condition using property 5. So, using property 5, meaning the same property na ginamit natin earlier. Kung mapapansin, itong z of t is equal to t cosine 7t, meron ng similar form nito doon sa ating equation, sa ating table of Laplace transform. Balikan natin ha. So, that is, t cosine 7t. So, sa table of Laplace transform natin, ito siya, t cosine omega t. So, pwedeng ito na lang yung gamitin natin. But, in the problem, we are specifically asked to use, saan na ba yun? Ito ba yun? Ayan, we are specifically asked to use property 5. So, gawin natin siya. So, remember, property 5 states, ito rin yung ginamit natin kanina. Ano ba yun? Pagbabaliktad ko, that pala z na yung ginamit ko. We have Laplace of a function of t times a function is equal to negative f prime of s, and that is also equal to negative d over ds f of s. So, in this case, alam natin, obviously, this is our t. So, ang cosine 70 natin, this is our f of t. So, we need to find f of s. We need to find f of s, and to find that, we need to get the Laplace of cosine 70. So, the Laplace of cosine 70 is equal to s over s squared plus 7 squared. This is our f of s. Now, we need to get the derivative of f of s. So, solving for the derivative, solving for d over ds f of s, or simply f prime of s. So, we will have f prime of s is equal to d over ds s over s squared plus 7 squared. Again, we need to use quotient rule for this one. So, yung quotient rule natin, we have s squared plus 49. That is our v times ang du natin is 1 minus s, that's our u, and our dv is 2s over v squared, that is s squared plus 49 squared. So, we will arrive at s squared minus 49 over s squared plus 49 squared. So, we substitute. So, we will have negative. Nakuha na natin yung f of s. Kunin na lang natin yung negative niya. So, we will arrive at s squared minus 49 over s squared plus 49 squared. Now, take note, if we use the one in the table of Laplace transform, we will also arrive at the same answer. And next, find the Laplace transform of f of t is equal to e raised to 2t sine 3t. So, in this case, pwede natin gamitin directly yung nasa table natin. Also, we can use property 4 pala. O tama, wala pala to sa table natin, or we need to use property 4 talaga. So, for property 4, ito lang naman yung sabi niya, e raised to negative 8t g of t is equal to g s minus a. So therefore, we just need to get g of s and then palitan natin siya ng s minus a. Yung s ay papalitan natin ng s minus a. So for this one, let g of t natin be sine of 3t. So ang g of s natin ngayon will be the Laplace of g of t. So remember, so ito yung paano natin ginagamit yung property for. Simple lang naman. Una, kunin muna natin yung g of s. And then kapag nakuha na natin yung g of s, yung s natin is papalitan natin ng s minus a. So ganun lang naman yun. So take note na ang form niya is e raised to at g of t. So if this is your e raised to at, then this is your g of t. That is why ito yun, sine 3t. Let us first find g of s, and that is the Laplace of sine 3t. You can use this, and we will arrive at 3 over s squared plus 3 squared. So we have omega natin is 3. So ito yon over s squared plus 3 squared or 9. So ginamit lang natin yung table of Laplace transform natin. And we will arrive at g of s is equal to 3 minus s squared plus 9. So meron na tayo nito. Now, ang gagawin natin, yung s natin is just papalitan natin ang s minus a. So therefore, ang Laplace natin ito is g of s minus a. So papalitan lang natin yung s ng s minus a. So we will arrive at lahat ng s natin, papalitan natin ng s minus a. Ang a natin in this case is 2. So therefore, we will have 3 over s minus 2 squared plus 9. Sorry, sumobra. So this is now our final answer. This is the Laplace transform of this f of t. Ayan, so that is it for this video. So take note class, ngayon is hindi pa natin nakikita kung paano natin siya ginagamit to solve for differential equations. Kasi inaaral pa lang natin mismo yung basic ng Laplace transform. So in the next topic, mas lalalim pa yung understanding natin with Laplace transform, and eventually, sa dulo is magsasolve na tayo ng mga differential equations, or we will find the solutions of differential equations.